What is the role of the coefficient c in a quadratic function? The coefficient c is the y-coordinate of the y-intercept of the quadratic function. When the term y-intercept is used, it is understood to mean the y-coordinate of the y-intercept. Recall that the y-intercept of any function is where the graph intersects the y-axis. This is where x is equal to 0. Let's start off by looking at the simplest quadratic function, f of x equals x squared. Here, a equals 1, while b and c equals 0. This slider shows the current value of c. Now, what happens when we change the value of c? The y-intercept changes accordingly. If c equals 0, then the y-intercept equals 0. If c equals 3, then the y-intercept equals 3. Is this still true if c is negative? Yes, it is. As the value of c decreases, the y-intercept follows accordingly. So if c equals minus 2, then the y-intercept equals minus 2. If c equals minus 4.5, the y-intercept equals minus 4.5. Is this still the case if b is not equal to 0? Yes, it is. Let's take a look. Say you have the function f of x equals x squared minus 4x plus 3. The graph of the function f of x looks like this. This point is the y-intercept. Notice that its y-coordinate is 3, which is the coefficient c. You should know that it doesn't matter what the two other coefficients, a and b, are. The y-coordinate will always be the same, namely c. Let's say you change a to 2 and b to 6, like this. The shape of the graph is different from before, but the y-intercept is still the same. You can also use this property the other way, to determine the coefficient c. In other words, if you have the graph of a quadratic function, the y-coordinate of the y-intercept tells you what c is. Say you were given this graph. Now you locate where the y-intercept is. It's at x equals 0 and y equals 1. This tells you that the coefficient c is 1. Pretty neat. The coefficient c gives you the y-intercept of the quadratic function. When the term y-intercept is used, it is understood to mean the y-coordinate of the y-intercept.